Hey everyone, Mr. Cameron here. Welcome to the first episode of Mr. Cameron's Lab, the show for students who want a review of things we did in class, or if parents, you're curious and you want to see what we're doing in class, this video is for you. So, today I'm going to address my 5th grade unit, which is physical and chemical changes. Now, physical and chemical changes are two different types of changes that happen to matter. A physical change is a change where the ingredient is altered in some way, but it doesn't change the actual physical properties of the original ingredient. For example, like this piece of paper. I can rip it into a million pieces, maybe not, and throw it in the air. It's still paper. It doesn't change the fact that there is still paper here. There's still small pieces, right? Just because they're smaller doesn't mean that it's a chemical change. I'll explain chemical change in a minute. Some other examples of physical changes are ice melting or breaking glass. Oops. A chemical change happens when matter is changed into something new. For example, this burning wood. The wood is being broken into tiny bits of smoke and ash. Usually a chemical change is irreversible. It'd be impossible to get the original wood back after burning it. Another type of chemical change is when two or more ingredients are combined to make something else. It's usually difficult to get the original ingredients back once the chemical change happens. Okay, well, one of the physical changes we've been experimenting with in class is dissolving. We've been using our classic example of a substance that we can dissolve, which is sugar. So, we simply add some water to a cup. Add a little sugar. And after a minute of stirring, the sugar dissolves. Looks like it's no longer there. When you dissolve a solid in a liquid, in science it's called a solution. There's a lot of different solutions. A lot of them that you actually eat or drink, like tea, soda, even motor oil. You shouldn't eat that one. But other different liquids that have anything dissolved in them, those are solutions. Even coffee is a solution. That's a good solution. If you're curious about what happens to a solid when you put it in a liquid and it dissolves, watch this video using an app that we use in the 5th grade to explain what happens to the molecules of sugar when it's added to water to make it dissolve. Okay, so molecule 1 represents water and molecule 2 represents the sugar. If we zoom in and we mix them around a little bit, come on, here we go. Now you'll see that the blue number 1s are bonding with the orange number 2s. That's because they have a high attraction to each other. So when something dissolves, it's because the two molecules, water and whatever you're mixing into it, have a strong attraction. When this strong attraction occurs, the water kind of pulls apart the molecules of the solid, in this case being the sugar, and breaks it down into the tiniest molecules, so we can't see it anymore. That's why when we dissolve, it's a physical change. It's still there. We know it's still there because if you drink it, it's going to taste like sugar water, but it doesn't look like it's there anymore. Another bit of evidence that tells us that dissolving is a physical change is that when you dissolve something in water, it changes the liquid's density. So we're going to use another type of solid that we can dissolve, salt. What we did in class is we wanted to see if we could figure out which of these very, very fancy liquids, beautiful, aren't they? Which one has the most salt in it? Now, if it has the most salt in it, we call it the most concentrated. When you add salt to this and dissolve it, it changes the density. Because when you add matter to matter, you get more matter. So if you're not doing a chemical change and something may be disappearing in the air, like when you do vinegar and baking soda and you get gas being released, if you're not doing that and it's a physical change, you're just adding matter together. So one of these liquids has the most density because it has the most salt. So my challenge for 5th grade was, can you figure out the order of which these liquids would stack? The reason that they stack is because if something is denser, it's going to go to the bottom, and something that is least dense is going to go on the top. That's the same reason that certain objects float. Okay? So I started us off here. I have the blue liquid on the bottom because it's the most dense, meaning it has the most salt. The next level would be the yellow, because the yellow has less salt than the blue layer, but more salt than the other layers. So if I take green and I start dripping this into our straw, you're going to see that the green layers itself right on top of the yellow. That's because it has less salt and the yellow has more. Now if we try our red, which is the least concentrated solution of salt, that will sit right on top like that. And there you have it, our liquid layers. I think the blue is leaking out on the bottom a little bit there, but you get the point. Well, that's all I have for you guys today. So thanks for tuning in. Hope you liked the first episode of Mr. Cameron's Lab, and I'll see you next time. What you making?
Coffee?
But what is it really? Yeah!